measurement of distance using a ruler or similar. So you find the height of the ramp, you need to find that, you need to find the travelled length of the distance from X to Y, should we discuss it, right? Away. Width of the card, if we're using card, distance between light gates that we use, and distance between dots on the tape if we're using that different method. There's lots of methods we can use here. I recommend you use explicitly light gates. So, measurements of time, such as a ticky tape, just put a stopwatch. Such easier. One thing to remember. Okay. And this is kind of what you're expected to be answering in here. So I ask you to write it in bullet points. Why do we think I'm asking you to write it in bullet points? What does it match?
The criteria.
Mark scheme.
Yeah, it matches the mark scheme, marks the criteria that the examiners are using to mark it. So literally, if you write one piece of factual information that lines up with what's in their mark scheme, easy tick. Makes their job easier, but we've had, don't give a monkey's about them, care about you. Makes it easier for them to give you marks. Okay? So, moving on to the next one. Our key terms, what do they mean? So I've got a way for you to remember these, okay? Sid, Sam. Now some of you may have come across this before when I've taught you previously. Okay, Sid, Sam. Okay? RC, what do you think RC stands for from the board? It's our control variable. Our control variable is what we keep the same in the experiment. Okay, we then have our independent. It is what we are adjusting, so it's what we're changing in the experiment. We then have our dependent, it's what we're measuring. This is a nice, easy way of remembering what each of the variables are and what we're using for them. Go. Yeah. Your pen doesn't work. Okay. Yes, you can, because I found one on my desk. Otherwise, we say no, because I don't normally have one. And then we independent variables. A variable that's changed in the experiment. So it's what we're adjusting, it's what we're changing every single time. The dependent variable is what is being tested or measured. The control variable is whatever we're keeping the same, so it's held constant. What we're keeping the exact same as the experiments. There's no point me seeing how long it's going to take for a piece of ice to melt, but I'm measuring it when I'm in the Sahara Desert and measuring it in, I don't know, the polar ice cap. Okay, I'm going to get different results each time. So I need to control specific variables that are going to be changing. How many independent variables should I really have?
One.
One. You should only be changing one thing in an experiment. That should be explicitly clear. You can measure more than one thing, that's fine, but you should only be changing one thing. Then our control group. Okay? Control groups are things that we leave absolutely blank. So for example, if I've got a reaction of, let's say, chemical reactions in water, I've got 3 different concentrations in 3 different test tubes, and I have 1 test tube of just water. That gives me my baseline where I can base all my results from that. It also allows me to see if I do get a result, well, has there been an error in my process? Okay? So it's something that's not exposed to the independent variable, but it's otherwise still the exact same. Might be asked, well, it's a very common thing to be asked, to improve an experiment. There's a couple of things we can do to improve it. We can talk about how we can make experiments more reliable and more accurate. Now, if looking at reliability, that means how likely am I to get the result that is valid? Okay? If I'm looking for accuracy, I'm looking at something that's going to get me the correct result every single time. What's the difference between accuracy and precision?
Precision is getting it one certain area.
Keep getting it
Not necessarily. You're not wrong with precision. Precision is getting your answers in one specific area. How is that different from accuracy?
You get the same thing.
Put your phone away. Actually engage in this. So you can simply phone and scroll TikTok, or we can actually, well, make use of the time you're spending here in a room in front of a teacher teaching. It seems like a bit of a no-brainer to me. Okay? So, precision, let's look at a dartboard, I'm hitting everything in one particular spot. If I'm accurate, I'm hitting everything on the board. Okay? So, a couple of ways we can improve experiments. Typically, an easy way of doing this is just by saying we repeat the experiment again, and again, and again. The more data we collect, the more accurate our mean average is going to be. It also makes it more reliable, because any anomalous results or results which don't fit that pattern, we can remove and make our data further accurate as well. So if we take more repeats, when we get more data points, what does that allow us to do? What statistical bit of analysis can we do? Let's say I take 3 repeats of data. What can I then do with those data points? Sorry, both of you at the same time, yeah? We can create a graph to show off our data, but let's say I've got repeat 1, repeat 2, repeat 3, okay? This one's giving me 8, this one's giving me 7, this one's giving me 9. What do we typically have in this column here? Okay. What can we do to make our experiment more reliable? I've got 3 sets of data. I can do what? Huh? No.
Oh, find the mean.
Find the mean, there we go. Take the mean average, okay? So take the mean average, okay, I can make my data more accurate, okay? Because it gets rid of all the standard error deviation from that. Okay, we can also mention using more precise equipment. If I'm trying to keep a temperature constant all the time, is it best for me to use a Bunsen burner to do that? Let's say I want to keep some water at 50 degrees. Is that going to be easy using a Bunsen burner? Is it going to be easy with me boiling a kettle and constantly having to refill a jug to keep it at a specific temperature? No, it's not. What piece of equipment should I use to keep a constant temperature? Think of something you might do on a Sunday with a little bomb in it that makes you a bath with what in it?
Cheers.
A single word of understanding.
Come on, lad, let's go.
Yeah, a bath with water in it, also known as a water bath. Don't write bathtub in your exam, but we might use a water bath. Okay? So, don't put bath bomb in your exam either, please. Okay? So, a student put 5 centimetres cubed of potassium carbonate solution into a test tube. Then added 2 centimetres cubed of calcium nitrate solution. A precipitate form was allowed to settle as shown in figure 4. The height of the precipitate was measured. Given the name of the piece of apparatus, the student should use one volume of potassium carbonate. So what does apparatus mean? A piece of apparatus. Yeah. So equipment, it's an object that we use it for something. So what can we use to find the volume of the potassium carbonate solution? What could we use? So find an accurate volume. You said beaker. So beakers fine for measuring larger quantities of volume.
Measuring cylinder.
Like you said, a measuring cylinder. Okay. Okay. Measuring cylinders are a smaller piece of equipment that allow us to make small intervals to measure volume, especially volumes of liquid. So, student repeated experiment as I'm showing in figure 5. Here, we've got 3 experiments where they've repeated it 3 times. Use the data of figure 5 to calculate the mean height of the precipitator. Who can explain how to calculate the mean? You should all be able to do some maths, but wants to show everyone how they can do it?
For me,
Yeah, how to calculate the mean?
I don't want to divide by 100.
Yeah, so you add 1, 2 and 3 together, and you divide it by what?
3.
3. So if I add 1, 2, 3, I get 6, I divide by 3, I get what? So do what Ariana did in our previous session. Now we need to make sure we're using the correct column while we're doing this. Okay, no, it sounds stupid. Let's make sure we're reading it from the correct one. We're not taking our data from the experiment column. We're taking it from the height of precipitate in centimeters. So adding 2.4 to 2.7 to 2.4, and we should get roughly 2.5, I think. Okay. So that is going divided by 3. That gives you the mean constant. Right. Now we're looking at practical skills. This one's very much common sense. Describe how a pure dry sample of the precipitate could be obtained from the mixture in the test tube. So, what's the command word here?
Describe.
Describe. What does describe mean?
Explain.
No, otherwise it'd say explain, wouldn't it?
Tell you what it is.
Tell you what it is? No, what's it using? The word explain. Explain means why. I don't need to tell you why you're doing these steps. I want you to describe what you're doing. So this is kind of just what. This is a what question. Okay? What do you do to prepare pure dry substance? So how are we going to do it? We've got a precipitate, so we've got a solid dissolved or not dissolved. We've got a solid floating around in a liquid. Okay? How do I collect it so it's pure and dry? So I've got none of the liquid and just the solid. So I can filter it and that removes the liquid part, so I'm left with the solid. However,
Evaporate.
put it away,